Welcome to another week of distance learning. Of course, we're May 5th through May 8th this time around. So we are just starting up Chapter 8, and we're skipping a few things. So we're going to start at 3D.2B, which what we're going to do is solving a system of three equations by hand. And then we're also going to be talking about matrices, a brand new topic for us. And so let's take a look at those systems of equations by hand. And so this is just the general gist of what we're going to do. And so you've done lots of systems before. You've used elimination before and substitution before. But what we're having now is we're going to do three equations of three variables, so x, y, and z. And so you have three equations, three variables. The big idea here is that you eliminate one of those variables, so you're down to two variables, and then you only need two equations. And then you eliminate another variable, so you're down to one variable, and you only need one equation. Once you're right here, you just get to solve that equation like you'd solve any other plane equation. However you solve, you get there for that first variable, and then you're going to substitute that back in over here to get your second variable. You substitute again back over here to get your third variable. And from there, what ends up happening is that you have a solution, x, y, and z, and your solution is a coordinate point. Now, I get a lot of questions from students over time with this about what they did wrong, and almost always it's a simple algebra error of either positive, negative, or not doubling with their elimination process or something of that nature. And so do be really careful, check your work early and often, and take your time. That's my number one piece of advice. As we get into our next section, which is going to be with matrices, so that's going to be brand new looking for us. And what a matrix is it is an array of numbers, which is in a specific placement. Here's an example of a matrix. These values, 1, 2, 3, 4, 5, 6, are in two different rows. Rows are horizontal, and columns are vertical. So if there's three columns, this would be what we consider a 2 by 3 matrix. And the number 3 would be an element or an entry 1, 3, because it's in the first row and in the third column. So that's just some basic information about matrices. We'll also be talking about matrix addition and matrix multiplication. Addition, you just add your corresponding entries with each other, and that's pretty straightforward. Multiplying takes a little bit of an extra steps and process to it. It is not as simple as addition or subtraction, and so you'll hear me say going across while you go down, and that while is really important for you as you're doing that matrix multiplication. We'll talk about that as we look at some examples. So let's take a look at this three equation, three variable system. As you can see, three equations, x, y, and z. And what our first goal is to do some form of elimination to get down to two equations and two variables. So what that means, they actually have to do elimination twice. So we're going to try to eliminate the same variable twice. And so as you take a look at all of your equations, think about elimination and which variable is easiest to eliminate. And after you do a little bit of research and reflection, hopefully you realize that the x's are the easiest to eliminate. Because what's going to happen is that I'm going to choose these two equations and eliminate them with each other. And what you notice is that x is going to cancel out. But we need to do that again. And so we're going to also eliminate an x by using these two equations, so the first and the third, because you have a positive 4x and a negative 4x. So by doing that elimination, it's pretty easy the way this is set up, because then you just get to add those together in order to come up with your first equation. And here's where you got to be really careful with your algebra. My x's eliminate. I have negative 4y plus a negative 5y, which is a negative 9y. 2z plus 2z is a positive 4z, and you have 34 plus 15, which would be 49. Okay, so that's my first set of elimination. Good, I don't have an x anymore. Now I do it again with my first and third. 4x and negative 4x cancel. Negative 5y and 2y, negative 5y and positive 3y is a negative 2y. You can see how easy it is to make a simple error there. And then you have 2z plus a negative z, and so that's just plus 1z. And that's going to be equal to, when you add up 15 and negative 4, equal to 11. Now I've done it. I've eliminated, and I have now two equations with the same two variables. It's not just any two variables down here. They have to be the same two variables. So we eliminated x twice. That's what we did. And now we're going to repeat this process. We have to do elimination again, but now I'm going to eliminate whatever's smart, which looks like, hey, I got this z, which can eliminate easier than eliminating a y. In order to do that, I'm going to have to multiply this bottom equation by a -4 in order to cancel out with that +4. And here's where students make their mistakes, of course. So I'm going to rewrite it. Being very careful and being very thorough is really important when you're doing this work. And now I'm going to have a +8y, a -4z, and a -44. All right, so now I've done it. I've taken these three equations. I've eliminated it down to 2. Now I've eliminated or set up an elimination of z. And so what I need to do is add up all these. And so I have a -y. The z's cancel out, which is good, is equal to a +5, which tells me that y is actually equal to a -5. And now I've solved for my first variable down here. I'm going to take that and substitute it back into one of these that has 2 variables. I'm not going to go back to the original yet. I'm going to go back to right here where you've got 2 variables in your equation. So I'm going to put -5 into this bottom one. And so then I have -2 times -5 plus z is equal to 11. That's -10. Oh, scratch that. See, that's not a -10, that's a +10. You can see how quickly you can make a mistake there. So that's a +10 plus z is equal to 11. So now we know that z is equal to 1. There you go. That's much better. So we're -5 and z is 1. And now you get to go back here, plug back into your original. Does not matter which equation you choose. I'm going to choose the first one because it's got the least values of the coefficients. So that means that I have 4x plus 3 times a -5 minus a +1 is supposed to equal a -4. So that's 4x minus 15 minus 1 is equal to -4. 4x minus 16. And now I have 4x is equal to a +12. So therefore, x is equal to a +3. So now your solution is a coordinate point x, y, z as a coordinate point. Make sure you go x, y, z. Right? Doesn't matter what order you solve for them in. You do have to put them in the order of a coordinate point. And so being careful with your work, meticulous and thoughtful, is going to help you find these values. These are going to be either integers or nice decimals. Right? Just as a hint, we're not going to give you anything with like irrational numbers and things like that at this point. Keeping it simple, integers or perhaps like a 0.5, 0.25 for your values. All right, moving on. Now let's take a look at some matrices. Here are examples of 4 different matrices, A, B, C, and D. And you see that matrix A and B both have entries that have an unknown in them versus C and D, which are just our numbers. Now first, let's talk about rows and columns. This first matrix is a 2 by 2 matrix because there are 2 rows and 2 columns. Remember, rows are horizontal, columns are vertical. So that means that matrix B is also a 2 by 2 matrix. Matrix C is a 2 by 3 matrix because it has 3 columns. Matrix D is a 3 by 2 matrix. All right, so now we're going to take a look about whether we can do any operations with these matrices. And so whether or not these operations are possible. And so addition and multiplication. So matrix A plus B. And so remember, matrix addition, you just multiply corresponding entries, and so they have to have the same entries. And so, yes, you can in fact do matrix A plus B, and you can do matrix B plus A. Not only that, but these two are going to be the same because addition, it doesn't matter which order you add in. Matrix B plus C, can you do these? Well, you have a 2 by 2 and a 2 by 3, so no, you cannot do that matrix addition. Matrix multiplication. Now for a matrix multiplication problem, you have to look a little bit closer. So we have matrix B, which is a 2 by 2, and we have matrix C, which is a 2 by 3. And so what we have to pay attention to is whether these values, the interior values, are the same. And you'll see that as we do this process, because as you go down, if you go across the row, you need to be going down the column. And so, yes, in fact, since those are the same, we can do B times C. And not only that, you're going to end up with a 2 by 3 matrix in the end. matrix C times B, so you're switching the order around. You might say, well, sure, if I can do one, you can do the other. Let's take a look. So C is a 2 by 3, B is a 2 by 2, and you say, uh-oh, these values are not the same, so no, you cannot multiply C times B. And so there you have it. You can see that just because you switch the order around in multiplication, it is not the same thing. It's not even possible in this particular example. That's an interesting thing about matrices. Matrices C times D, so 2 by 3 times a 3 by 2. Yep, that works. And a 3 by 2 times a 2 by 3 for D times C. Yes, that also works. And so we're going to take a look at a couple of these examples here. We're going to do A plus 2B. And so we'll start with matrix addition, the more simple process here. So I like to write this out. So matrix A is a 3x plus 1, 5, negative 6, and 4x. And I'm going to add to it 2 times matrix B. And so this is what we call scalar multiplication. So it's like a scale factor, so scalar multiplication. And so you just get to double everything that's in matrix B. So I'm going to do that as I go here. So 2B is actually going to be negative 6, 10x, 22, and negative 2. All right, so now those are what we're going to add together. In our solution matrix, you just add together the corresponding entries. So 3x plus 1 plus a negative 6. Okay, well, it's just a 3x because those are my combining like terms part here. And 1 minus 6 is a negative 5. That's my first entry. And then you have 10x plus 5 in the top right. And then you have negative 6 plus 22. So that is going to be a positive 16. And then you have 4x plus negative 2, or just 4x minus 2. And there you have your matrix addition for A plus 2B. All right, now let's do matrix B times C. This is going to take a little bit more work for us. And so matrix B is going to be negative 3, 5x, 11, and negative 1. Matrix C is negative 2, 4, 10, 1, 0, and 5. All right, so as we take a look at this, I'm going to zoom in here because we're going to need to pay attention to our space that we're using. So what I've said before is that we're going to move across a row while you move down your column. And you'll see that in how you do your matrix multiplication. You do not get to multiply just this entry times that one. And so as we multiply, then what that means is that we are going to do negative 3 times negative 2, so negative 3 times negative 2, top 1 entry in here, and then we go across while we move down, so then I'm going to add to that a 5x times 1, so 5x times 1, and then that will be our actual solution. So I'll write our solution matrix down here, and so that is going to be a positive 6 plus 5x. That's how that works for that first one. And now I repeat. So I'm going to move across that same first row because I need to move down my second column. So I stay in my first row up here while I move down my second column. And so I'm going to do that in green. So that's negative 3 times, let's use a dot here, negative 3 times 4, and I'm going to add to that 5x times 0. Okay, that's not so bad because then negative 3 times 4 is just going to be negative 12, right? I'm actually going to keep that in green, I guess. And now for my last one here, I have to go across this row again and then down that last column. And so now I have negative 3 times 10, and I'm going to add to it 5x times 5. And so now that is going to be negative 30 plus 25x. And that's how you do your matrix multiplication, what I've said about going across a row while we move down our column. And so let's go down here. So now I move down to my second row because I went all the way across. Now I'm going to move down back to my first column. So now I have 11 times negative 2 plus negative 1 times 1. Right? And this process can get complicated, but you just have to practice it. Keep doing it, and it will become clear. This total is negative 22 plus a negative 1, so that's negative 23. And as I keep on going here, so now I'm going to go across that second row down my second column. And so I have 11 times 4 plus a negative 1 times 0, so that is 44. And finally, let's see, pink, I guess, will work here. And so I'm going to go 11 times 10 plus negative 1 times 5. So that is going to be 110 minus 5, so that is 105. And there you have your matrix that comes from the product of B times C. A lot of steps in there. But anytime you have something which is an unknown or a constant in there, you have to do it by hand. And you'll see me go across the row while I move down the column. So you stick in that first row until you've gone down all of your columns. Then you move down to your second row, first column, second row, second column, second row, third column, and you repeat every single time. Okay, so let's go back here. We have one more problem to do, and that is to do C times D. And you can see that this process can get intimidating if it becomes a bigger and bigger matrix. However, this one is a 2 by 3 matrix times a 3 by 2, and so I think that if you take a look at how these problems worked, we're going to end up with a 2 by 2 matrix. You just have a lot of addition. So what I'm going to show you now is that when you don't have a variable or an unknown in your matrices, you can use your graphing calculator to do this work for you. Again, what we did here is important with addition, and what we did here with multiplication is also important, because if you have an unknown or a constant, you have to do it by hand, and you will be expected to do that by hand on quizzes and tests. But when you have no unknown or variables in your matrices, you can use your graphing calculator. So we'll take a look at how to use your graphing calculator now. So let's take a look at how to do this on our calculator. And so first of all, you're going to look for where the matrix menu is on that calculator, which is right here. So we're going to hit second matrix, and it brings up this menu. As you can see, I've already got some matrices ended up in here, and you will too over time, and you can just type over them, so we'll show you that. But names, that's where you're going to use your matrices in other calculations back in your home menu if you wanted to do something with that. Math is to do complex operations on the matrix, which we'll use part of that later. And then edit is where, of course, you create your matrices. So let's go ahead and edit one. So I'm going to go over to edit. And it doesn't matter which one, you can always write over it. So that's what I'm going to do. I'm going to write over matrix A. You might not have any in there, and that's fine. And you can see what it starts you up at is with your rows and columns. So I'm going to start with matrix C here. Even though it's called A, it doesn't really matter. So I'm going to say that this is a 2-row enter, and then 3-column enter matrix. And now I'm going to type it in. So -2 is my 1, 1 entry. So hit enter. And then 4 is my 1, 2 entry. And you can see that it just kind of moves across my row. 10. And then 1 is my 2, 1 entry. And then 0 again. And then 5. All right, so there is my matrix. It's matrix C on this presentation at least. And so if I can use my names menu, and if I just hit enter right now, it says here's matrix A. And if I type it, okay, there you go. There is my matrix, my 2 by 3 matrix that I just entered. And so now we want to enter matrix D so that I can do some matrix multiplication. And so I'm going to go back in here. Go to edit, and I'm just going to do that in my second one here. So that's B. Don't let the letters confuse you. They're just placeholders. So edit, and now this is a 3 by 2 matrix. And so now I enter these values: 1, 5, -3, 2, 0, 4. Make sure you hit enter every single time, including right after that very last one. And now you're going to quit back to your main menu. And now, if I do matrix and I use my names, go down to my 3 by 2, hit enter, that one will pop up. And what we're going to do now is we're going to do matrix C times D on my presentation. And in my calculator, that is matrix A multiplied by matrix B. And all you do is hit enter, and there you go. There is that 2 by 2 matrix we talked about that we would have, even though they both started out with values of 3s in those rows and columns, but now it turns into a 2 by 2. So negative 14, 38, 125. And just for good measure, if I switch those around, we will see what happens if we try to 3 by 2, and then matrix A, so now 2 by 3, and you multiply those by each other, and now you end up with the 3 by 3 matrix, right? So it is possible to switch the order around and still be able to multiply, but not guaranteed that those are going to be the same, and here's case in point, 2 different values. But that's how you use your calculator to do matrix multiplication. Of course, you could do it with addition, scalar multiplication if you're doubling, tripling something, or subtracting. When you cannot use it is if you have a variable or an unknown in that matrix. Your calculator does you no good, so you do need to know how to do those by hand.